Hello, my name is Tomasz Janaszka and I am Solutions Architect at Codylime. Today I would like to present the tool Characteristic-Based Memory Consumer. I will tell what the tool is, why you might need such a tool, and also I will list some alternatives and demonstrate how to use the tool. This is the simple Python application that is consuming memory according to the specified time characteristics that we call pattern. And the pattern can be expressed in different time scales. Usually we are using such a tool for testing system stability, for testing application under high pressure of memory consumption. Also, we can use such a tool for tuning our infrastructure and in general to troubleshooting memory-related issues. At Codylime, we needed such a tool for for modeling various workloads having different patterns, for testing advanced resource allocation, eviction, and scheduling strategies in a computing cluster. For sure, there are some open source alternatives that could be also used, but there are the list of some of them on the slide. But in general, we didn't find an easy way how we can provide the pattern having various size, so that we decided to write our own tool. How to use the tool? As a Python process, it can be executed on localhost, on the virtual machine, also as a Docker container, and as a pod in a Kubernetes cluster. First of all, we need to clone our public repository, and also we recommend to use an external tool. You have link here. It is called MEMUsage UI that could simply draw a chart showing how our process is consuming the memory in the real time. So let's switch to the console. Let us switch to the console and be sure that we have the Python and pip installed. And next, just clone our public repository. This is on the GitHub, Codylime, and the name of the repository is RAM utilization. The code is in the subdirectory memory consumer, and the patterns subdirectory is containing the example patterns that we will be using in the demo. And what we need to do is just to pip install dot, then our program will be installed and can be used. We can install we can just show how to run it. First, we will display the help and the parameters of the program. But before the first run, we just switch to the another console and install the additional external tool that will show how our process is consuming the memory. This is the pip install MEMUsage UI. And we are just starting the program by simply writing. And we should have on the localhost and port 8080 the tool that could easily select the process running. And here we will be displaying how the memory is consumed by the particular process. So let's run our tool. The only required parameters is just the pattern. So we are providing the reference to the file that is containing the pattern. and let's start our application. It displays some arguments that we are and default arguments of our program, and the application is starting allocating them according to the pattern. And we could easily see it by filtering the processes. Here we could see this is our application. And now this tool will simply show how our program is consuming the memory in time. After a few minutes of observation, we should receive a chart like on this slide. So we clearly see that our process is consuming memory according to the given pattern. What is inside the application? Our pattern is just the CSV file with 2 columns. N stands for second, and the memory represents the percent of the memory to be allocated by the program. And this is the characteristic draw on chart. Next, our application is just when starts, it reads and compare the time and takes the value from the pattern and allocates appropriate memory in its internal memory array. After 5 seconds, because this is default step for the next allocation or deallocation, it reads another value and adjusts the memory allocated in memory array, and so on. By default, the application is running in the mode of the continuous loop. We could create another patterns. S patterns are when we are expressing the values for seconds. M pattern when we are expressing the values for minutes. In that way, we could obtain the 1 hour long pattern. If we need more granularity, we could also express the values for minutes and particular seconds. And also, we could create longer patterns. For instance, 1 day long pattern. We could create the file which contains the columns H and M when we are expressing the values for hours and minutes, and either for 1 week long patterns where we are defining the time for the values for particular days in the week, hours and minutes. So in general, we could create the patterns as we wish for our purposes. Also, we could just record how particular applications are consuming the memory in time and use such a data to create the pattern and to replicate such situation using our tool. There are 6 options that we could add to our program. This is the maximum memory. By default, this is 1 GB. We could change it. Also, we could change the interval between consecutive allocation steps. We could add the noise to the values in the pattern. We could add linear trend, defining the slope. We could also force the application to start from the beginning of the pattern, and could set the duration of the process. All these options are described in the README. So now we will demonstrate how to run our process with all those options. So let's switch again to the console. Now we will start our process with all these additional options. Let's start our process for the same pattern. And we could see that our process is working. And after a few minutes of observations, we should receive the chart as here, when we could see that there is a slope, there are the noise in the values. So in this way, we could just model various conditions for the memory consumption. And now I will demonstrate how to build the Docker image of our tool. It is quite simple. If we list the directory, we could see that the Docker file is prepared. So now the simple command allows us to build the Docker image, Docker build tag, and dot at the end. After a couple of seconds, we should receive the Docker image. Let's check. And now let's start the Docker image, the application as a Docker container. The command is as follows. It's a Docker run, interactive mode, IT. Remove after the application is finished. Name of the image and the parameters that we are talking earlier. Let's start it. And we could see that our program is now working as a Docker container. In order to run these various processes in the Kubernetes cluster as a pod, for sure we have to prepare a manifest. It is the standard one. The key points here is just we have to provide our name of the Docker image, and we have to express the arguments of our program in this way as a list of option names and parameters that are separated by the column and provided in the double quotes. And now I will switch to our real cluster. This is one node, one worker. When we run our program with different patterns, and we could see how we load the whole cluster node in order to investigate some issues related to allocation of resources, eviction, and scheduling. So using this one tool, we are able to model various workloads and to provide some precise conditions for memory allocation in our cluster. So this is the end of our video. I will encourage you to see this repository, to look at the README. All these options are explained. Feel free to use it. Feel free to modify it, adjusting to your needs. I would like to thank you for watching this video. Stay tuned. Bye-bye.